Hey, what's up, guys? This is Chung here again. So this time I want to talk about today's uh, daily challenge, which is number 1288. Remove covered intervals. So this is like another interval problems where of course, every time when you see interval problems, you need to sort it in some way, right? Okay, so again, so basically we have a bunch of intervals here, right? And you need to remove the total covered interval. So an interval is covered by another one if it's basically it's within, let's say there's interval A and B and C and D here. A is covered by AB is covered by CD only if the C is smaller than A and D is greater than B. Basically, only when there's like interval and there's like another interval that's starting is before this one and ending is before this one. Okay, that's how you call like this interval is covered by the second one. Okay, so and it asks you to remove all the covered intervals by any of the other intervals, and then it asks you to return the number of remaining intervals. So for example, this one we have 1, 4, 3, 6, and 2, 8. Basically, the 3, 6 is covered by 2 and 8. That's why I mean the 3, 6 will be removed, and the remaining is 2. Okay. Yeah, those are a bunch of other like intervals, the bunch of examples here. So, I mean, let's say we have a bunch of intervals. I mean, the easiest way is just we just sort by the starting time. Okay. If we simply sort by the starting time, okay, and then we are guaranteed that like and the second one, right? And the second one will be before I mean the current one will be for the previous one. Basically, we're sorting by the start time so that I mean the first condition is met. Okay. Now we just need to check if the ending point is within the previously intervals. To be able to do that, right? I mean, of course, in this case, I mean, since we have a here, oh, sorry, we have these intervals here, and when we see these intervals, we see okay, so the current ending is before the previously ending. Basically, what this means that we'll be maintaining like the biggest the biggest ending previously, okay? And this one is simply it works because we'll process this interval first and then this one. But the issue is, let's say we have two intervals that starting, I mean, have happens to have the same start time. So let's say this one. I mean, if that's the case, right? I mean, based on if we only do a simple sort, if we only do a simple sort by this intervals dot sort. So which one will come first? This this one. So why is that? When the starting time is the same, so this interval is basically the sorting will sort the ending time accordingly. And in this case, this ending time is smaller than this one. That's why basically it won't give us the result. Okay. So what we are trying to achieve here is that we always want to in case of the same starting time, we always want to process the ones with the bigger ending time, right? So that later on when we process the smaller one, we can compare this one. We can compare with the current one, the current ending time with the previously biggest ending time. That's how we can uh, that's how we can determine, I mean, if this current interval is covered by the previous one. Okay, so with that being said, like I said, I mean, in this case, I mean, since we have basically we won't sort by the first, we want to sort by the start, but we want to sort it uh like descending order for the ending time. Okay, That's why we need to create a lambda key here. Lambda, okay, equals to key, right? Sorry, key equals to lambda. Sorry, key equals to lambda. And then X here, right? So, and here will be basically we'll create our customers a customized key here, where the first one is X0, and the second one is, since we're going to sort it like from a descending order, we simply can just use this, right? Basically, we just do use the negative value to sort the second one. So now we can do a for loop here, right? So start and end in enumerate interval, okay? So like I said, we will have like removed 0, and then we'll have like max ending time, okay, equals to 0. So basically every time when we have like intervals here, all we need to check is that we just need to check if the current ending time is smaller or equal than the previously max ending time. So this one, since we can start from the first intervals because the uh, because the ending time, right? Because the ending time will always be greater than 0. So which means, so for the first one, it will never go inside here. But and here we just need to maintain this one, right? Maintain the current ending time with this, with this ending time. Sorry, the max ending time, not the current one. And with this one, right? So now, if this the ending time is smaller or equal or smaller than the max ending time, then we know, okay, so this current intervals must have been covered by one of the previous intervals, so, right? So that we can simply add this removed by 1. Yeah, and then here we simply return the length of the intervals, right? And then minus removed. That's gonna be the answer. Yeah, run the code. List and uh what? Oh, sorry. Uh not enumerate, sorry. I don't need the index here, just the starting time and ending time. Cool. Accept it. Submit. Yeah, so it's accepted. All right, cool. So I mean, it's a pretty straightforward interval problems where you just sort, and then the sorting is a little bit different here. Basically, we sort by the start time, and then uh the ending time in descending order, so that we can simply and then we're maintaining like this one, the maximum ending. You know, you know, every time when you sort by the start time for in terms of in for this interval problems, you always most likely you will be you need to maintain like the maximum ending time to do some checkings here. In this way, in this problem, we just check if the current E is within the current max, so that we know, okay, it's totally covered. It's completely covered by the previous interval, so that we can increase this one. Yeah, and of course the time and complexity is unlog n, right? Because we do a sort here, and here's n, so it's n log n. Cool. I think that's it for this problem. Thank you so much for watching this video, guys. Stay tuned. Bye bye.